Hi, today's video is all about recognizing different steels. There are several tests that we can perform on steel to help us determine which type of steel we have. We're talking here about compression tests, traction tests, hardness tests, and tests such as crystallography. Now these tests are very accurate and would help us quite a bit in determining which steel we have, but they require large amounts of very expensive equipment. Home machining is all about having fun, not going into debt. So what can we use that isn't too expensive that will help us determine which type of steel we have? Now the first thing that we can do to help us identify different steels would be to not have to do it right from the get-go. So when you buy a piece of bar stock, make sure that you identify it clearly all along its length, so that even if there are small pieces left at the end, you'll know what they are. Now that seems like a no-brainer, but you would be surprised to find out how many people identify their bars on the ends. And obviously once the end of the bar is cut off, well, you have no way of really knowing which steel it was. Now you have to remember that steel has a very long shelf life. So the method that you choose to identify it has to last over the years. Make sure to choose a paint or a method of identification that will not erase after a few months. Our hands, our noses, our eyes and our ears, a glass bead, a magnet, a file, and a pedestal grinder. These are the tools that we're going to use to perform these simple tests. The first test that we're going to talk about is a spark test. And to perform a spark test, we're going to need a pedestal grinder in good working condition. We're going to need an assortment of known steels and obviously the unknown piece of steel that we're trying to define. So let's go take a look at what a spark test looks like.
If, after visual inspection of the part, you're still not sure of what you have, you can perform a spark test. Spark tests are quite simple to perform. All you have to do is compare the sparks produced on the pedestal grinder by a known test piece to the sparks that we're going to produce with the part that we're trying to define. Now, doing the test is quite simple, but it requires a lot of preparation. In this case, I've prepared 5 test pieces. 1 piece of low-carbon mild steel, 1 piece of medium-carbon alloy steel, 1 piece of tool steel, 1 piece of free machining steel, and 1 piece of stainless steel. All I have to do now is compare the sparks that these test pieces will produce to the sparks produced by the part that I'm trying to define. Perhaps you've never noticed, but when you grind steel on a grinding wheel, different types of steel produce different types of sparks. The clues that you're looking for are length of spark. Do the sparks make it all the way around the grinding wheel? The color of the sparks. Are the sparks white, orange, or red? The trajectory of the sparks. Do the sparks describe straight lines, or do they fork out before they're done? Are there a lot of carbon bursts in the sparks? These are the things that we're looking for to compare between our piece and the test pieces. Let's start by looking at the different sparks that we obtain with our test pieces, and we'll start with our stainless steel, followed by our free machining mild steel. Now let's try our tool steel. Our medium carbon alloy steel. And finally, our low carbon steel, the plain steel. Now let's compare those parts to the part that we're trying to define. Now the spark test is just that simple. And by comparing the sparks from my part to the sparks from our test pieces, we can deduce that this part is stainless steel. And that surprised me because I thought it was mild steel. So just to make sure, I'm going to use a magnet, because I know that most stainless steels are not attracted to magnets. It isn't attracted, so this is a piece of stainless steel.
Now that test was quite simple, but can we get more information from it? And the answer is yes. Now in the previous test, we saw that we can use our eyes to compare the sparks from one part to the sparks from another part. But we can also use our hands, we can use our noses, and we can use our ears to compare one part to another. Now if you pay particular attention to the odor produced by a grinding operation, you'll notice that different steels have slightly different smells to them. The most obvious comparison is between a plain high carbon steel and a plain low carbon steel. When grinding, you'll notice that the high carbon steel has a very strong odor, whereas the mild plain carbon steel has almost no odor to it. Now obviously recognizing steels by smell is not something that's quite easy to perform, and it requires a lot of experience. But if you do pay attention to the smell of a steel when it's being ground, you'll eventually be able to differentiate several types of steels just by the odor. Now the last thing that we can get from a comparison spark test, well, it's the sound. Now sound is vibration, and we can hear vibrations, but we can also feel vibrations with our fingers. Now we can use sound to determine a type of steel because each type of steel has a slightly different sound to it when it's ground. Now these spark tests aren't accurate enough to differentiate two alloys that are quite close to one another, but they are very practical for differentiating large families of steels. Now these spark tests are quite good to determine whether a steel is a plain carbon steel, an alloy steel, a tool steel, or even a stainless steel. They can also be used to differentiate low, medium, and high carbon steels. Now once we've determined what large family of steels we have, well, it would be important to find out, is this steel hardened or not? If we want to determine the hardness of a piece of steel, well, we can use our little glass bead and a file. So let's go take a look at how we can use these tools to give us a very good idea of how hard our steel is.
A simple and inexpensive way to help us determine how hard a piece of steel is would be to make ourselves a small scleroscope. Scleroscopes use the height that a bead will bounce off of a surface to determine its hardness. In our case, we're going to use our glass bead. To help control the bouncing of the bead, I've chosen a plastic cylinder which I've graduated. And now all I have to do is place the bead in the cylinder and let it drop onto the surface that I want to measure. For this test, I've chosen 4 pieces. The first piece is a piece of aluminum. The second is a piece of mild steel, not hardened. The third is a piece of medium carbon steel that is hardened. And the fourth is a piece of tool steel that has been hardened. The hardness of my test pieces should go from quite soft to very hard. What I expect to see here is a short bounce on the smallest part, the aluminum, and a quite high bounce on the hardest part, the tool steel. But pay also attention to the sound of the bouncing bead. Also to the number of bounces the bead performs on each type of part. It's just that simple. We clearly hear, see, and count that this is the softest material and that we get progressively harder as we move towards the hardened tool steel. Another method to help us determine the hardness of a piece of steel would be to use files. A bit as we've seen during the Metcalfe experiment. But this time, instead of using one file, we're going to use two files. One file with a very fine tooth form and one file with a very coarse tooth form. How it works is quite simple. We know that a fine tooth file will easily cut a piece of mild steel, and that a coarse tooth file will also cut that mild steel with ease. However, if we try and cut a piece of medium carbon steel that has been hardened, we will discover that the fine tooth file cuts it reasonably well, but that the coarse tooth file doesn't cut very well at all. If we push it one step further and try to file a piece of hardened tool steel, we'll discover that neither of the files will cut the tool steel. So all I have to do is try both files on the part that I'm trying to determine the hardness of. Starting with the coarse tooth file, followed by the fine tooth file. On this part, both files cut quite well. This is not a piece of hardened steel. I can now redo the test on a different part. Starting with the coarse tooth file, followed by the fine-toothed file. Now I can see, hear, and feel that the coarse tooth file did not cut very well, but that the fine-tooth file cut a lot better. So this is a piece of hardened medium carbon steel. Now let's do the test over again with the third part, starting again with the coarse tooth file, followed by the fine-toothed file. I can clearly hear and feel and see that this piece was not cut by either of the two files. So this is a hardened piece of tool steel or high carbon steel. Now this test is just that simple. But a small suggestion would be not to use your best files to perform it.
Well, we've seen that we can use spark test to give us a very good idea of the large family to which our steel belongs. And we've made a little homemade scleroscope, and we've seen how to use files to give us a good idea of how hard a piece of steel is. Now, is there anything else that we can do to give us an even better idea of what type of steel we have? And the answer is obviously yes. Now, the last method that I'm going to talk about today is probably the first method that you would want to use to help you to determine what type of steel you have. I'm talking here about a visual inspection. Now, the best way to learn how to go about this is to actually do some evaluations. So let's go over to the surface plate and evaluate different types of steels for this visual inspection.
So I don't want to make this any more mysterious than it has to be. So I'm going to tell you right off the bat what exactly we have on the table. So all the way in back here, we have a piece of structural steel, angle iron. In front of the angle iron and parallel to it, we have 3 pieces of tool steel. In front of the tool steel, and at a slight angle, we have a selection of mild steels, or if you prefer, low carbon steels. Beside that, we have a selection of medium carbon steel. And in front of all that, we have a bar of stainless steel. Now if we start with the most obvious, way in back here, we have a piece of structural steel, in this case angle iron. Now structural steel is almost always a mild steel. It has a surface finish that's black and scaly. And obviously it is a steel that cannot be hardened. It is, however, important to note that structural steel is the type of steel that is the easiest to weld. The next group I want to take a look at is the tool steels. Now tool steels come in short bars. As a general rule, 3 to 4 feet long maximum. Tool steels have a bright, silvery, almost brilliant appearance. Now they have that appearance not because it is the nature of that steel, but because manufacturers want these bars to look good. After all, they are quite expensive. Now that beautiful appearance is a dead giveaway. And as soon as I see it, I have a strong suspicion that I'm looking at a piece of tool steel. The next group I would like to look at are the mild steels. Mild steels are available in a vast number of different forms, and in bars in lengths up to 20 feet long. Now the surface appearance of mild steel is generally a cold rolled appearance, which means that it is grayish in color and has a dull, pitted surface finish. That doesn't mean it's dirty, it just means it's not shiny. The next group would be the medium carbon steels. And they are by far the hardest group to identify visually. Some medium carbon steels are hot rolled and present a black, scaly surface finish that resembles the finish that we had on our structural steel. Some medium carbon steels are cold rolled and have a finish that resembles the finish of our mild steels. Then again, some good quality medium carbon steels that have a ground finish that looks a lot like that of the tool steels. Finally, we have our stainless steel bar. Stainless steels have a very silvery appearance, but oddly enough, they aren't particularly shiny. They have a dullness to them that other steels just don't have. So when I see a very clean, silvery piece of steel that has a dull appearance to it, well, that's a good clue that it's stainless steel. Now, there's not a single test that we've seen that by itself will give you a 100% positive answer to the question, what type of steel is it? You'll have to use combinations of these tests to get to a point where you are quite certain of what you have. Really, the best way to know what type of steel you have is to deal with a reputable dealer and identify properly each steel bar that you buy.
Another thing that we could do that would help us to determine which type of steel we have is a hardening operation. In the last video, I mentioned that low carbon steels cannot be hardened, that medium carbon steels can be hardened but to a medium hardness, and that high carbon steels can be hardened to a high degree of hardness. We can also remember that I mentioned that plain carbon steels needed to be quenched in water, and that alloy carbon steels were generally quenched in oil. The reason being is that plain carbon steels require a huge thermal shock to harden, and that most alloy carbon steels can be hardened with a much smaller thermal shock. Now we quench alloy carbon steels in oil, not because they wouldn't harden if we quench them in water, but because quenching them in oil cools them more slowly and reduces the chance of deformation. Now if I have a steel bar and I take from that bar two small pieces that I heat treat and quench, one in water, one in oil, I can use the results of that hardening operation to determine what the content of the original steel bar was. If after the hardening operation I can see that neither of the parts have hardened, well, that means that I have a low carbon steel. If I notice that only one of the two parts has hardened and that it has hardened to a medium degree of hardness, well, that indicates that I have a plain medium carbon steel. If both pieces have hardened and they are both hardened to a medium degree of hardness, well, that's a good indication that I have a medium carbon alloy steel. If, however, I notice that both parts have hardened and that they have hardened to a high degree of hardness, well, that's a good indication that I have a high carbon alloy steel. Finally, if I notice that only one of the two parts has hardened to a high degree of hardness, well, that's a good indication that I have a plain high carbon steel. I think at this point we have a good palette of different types of operations that we can perform. So, happy machining!
There you go.